Section 6.2, continuing to look at functions, and today we're taking a look at, well, how to compare functions. So here's our warm-up. We're asked to identify the parent function of each of the following, graphs and tables below. Looking at this number one on the the left side here, talking is really hard for me apparently today. Uh, Kind of comparing some things using like first, second, third differences, all that good stuff. Now this is a little different because typically we've had like X and Y running horizontally. Now we've got them running vertically, but we can still do the same thing. So looking at our Y changes here, we're going to say going from 5 to 7.5, that's going up plus 2.5. Going from 7.5 to 10, that's also plus 2.5. And you'll notice this pattern keeps going. You're increasing by 2.5 every time. So as a result, we call those the first differences. They are constant, so this is a linear graph. Now looking at number two, it's something we've seen before. We haven't dealt with this a ton lately, but that's just a square root graph. It's only got that top part. It's kind of like a tipped over parabola, but only half of a parabola. So our goals for this lesson are to compare functions. Simple and straightforward. Let's start off with an example. We got two taxi companies, or maybe it's like not taxis anymore. Maybe it's like Uber and Lyft. They're offering competitive services in the metro area. Company A charges $5 up front and 50 cents per mile after that. Company B charges $12 up front and then 20 cents for each mile. We're asked to write an equation and graph both functions and interpret the results. So let's just start off with some notation here. We're going to say cost is our C, and then M will be for miles. Now we're going to have two different companies, so we're going to say the cost for company A is, or sorry, I guess if we're doing it proper notation, cost is a function of M for company A. So looking at their information, it's $5 up front and 50 cents per mile. Now putting this into more standard form, I'm going to say 0.5 or 50 cents per mile plus $5. Similarly, company B, let me switch colors so that I can color code this. Company B, so C sub B as a function of miles, they're charging 20 cents per mile, so that's 0.2 times M plus $12 up front. Now to help us make a table, I'm going to suggest we just kind of like, well, to make a graph, I should say, let's make a table out of this. So we're going to have miles, we're going to have company A, which I'll do in red, and then company B, let's do that in blue. So starting off, let's just start off with 0 miles. So 0 miles, if you plug that into company A, you're going to be charged $5. Company B will be $12. Now that seems a little ridiculous because like why would you not go anywhere if you're getting in a cab or a Lyft or whatever? But that's where I'm going to call like the butt in the seat cost. Like how much does it cost to just sit down and then after that you're going to be charged per mile. So if I plug in 5 miles, so if I'm going 5 miles, plugging into the first one, we're going to end up with $7.50. Plug that into the second equation, it's going to be $13 total dollars. If we go a total of 10 miles, we're going to be up to $10 for company A, and then we're going to be up to $14 for company B. Let's see, let's go 15 miles. Go 15 miles. We got $12.50 for company A, and that'll cost us $15 for company B. Let's go a little bit further. Let's do 20, and by the time we get 25, we should be good to go. $20 for 20 miles for company A would cost a total of $15. For company B, it would cost $16. And for 25 miles, it would cost $17.50 for company A, while just $17 for company B. Kind of modeling this, we're going to need to go all the way up to, let's see, 25 miles, and we're going to, well, let's go even a little further than that. I'm just going to say on our horizontal axis, that's going to be our miles. On a vertical axis, that's going to be our cost. Starting off at 0 on the horizontal axis, let's just go up by 5. So I'll go 0, 5, 10, 20. So I guess every tick mark is going to be 5, but every other tick mark is going to be 10. Just kind of getting like a little beyond the information that we have here. For the vertical axis, I'm going to do pretty similar scale, actually. Every other is going to be 10, so every tick mark is 5. So, with this information in mind, let's start off with, I'm going to do company A. So company A for, well, just the butt in the seat, that's going to be $5. For 5 miles, it's going to be $7.50. For 10 miles, it's going to be $10. It's just going to keep going up at this same slope. So you can keep that slope going because this is just going to be a linear graph. So draw as many points as you can so that way you can draw the straightest line possible. And that's what company A looks like. Company B starts off at $12. So like this is $15. So $12 is going to be just a little below halfway. Let's see, 13, oops, sorry, that didn't draw. $12. At 5 miles would be $13. So a little above. At 10 miles would be $14. At 15 miles, it'd be 12. Oh, sorry, I was looking at the wrong number. 15. And we're just gonna keep going slowly up. So if you want to like pick a couple of nice points, like you're gonna start getting some nice points there. Let's see, we'll just keep going. So 16, 17, and it's just gonna keep going on that slope. So taking a look at this, looks like the further you go, the more it's going to be a better deal to go with company B. So I'm going to say company B is better for longer distances. In other words, company A is better for short distances.